Guys, here's your guys' homework on conditional probability. Okay, so number one, we have this table. Okay, so make sure you guys just look over this table, kind of get used to it and whatnot, and then let's look at part A. So in part A, it has probability. Find the probability that an employee has less than a high school education. So when we take a look at this, we have, well, first of all, you guys have to know how many total are in here, okay? So if you add all those numbers up, there's a total of 1,200, okay? 1,200. Now, employee has less than a high school degree. Well, this is where we have where employees are less than high school degree. It's right there, okay? So what we have to do is, all we have to do is just add those three. So we have to add all those three and then divide it by the total, which is why we have all those add together divided by 1,200. Now when you simplify, you get 107 and over 1,200. That decimal, if you guys put that in your calculator, it's 0.0891. To get it into a percent, move this decimal 2 places over, and that will give you guys from decimal into a percent, and then round to the nearest tenth, which would be 8.9%. All right, part B, it says employees earn under 20,000. So here are the employees that earn 20,000. So we have to add all of those together and divide it by 1,200. So that's how I got this, you guys, for 296 divided by 1,200. That, if you put in your calculator, is 0.2466. And I could actually use, no, it isn't, oh, the pointer tool. So this, you guys, you just make this into a percentage by rounding it to 2 decimal places. So it'd be at 24.66. Round that to the nearest tenth. So that means it's going to be 24.7%. Okay, moving on. Part C, it says employees earn over 30,000 and has less than a high school degree. Okay, so employees earn over 30,000. That is this category, right? And then it says and has less than a high school education. Well, less than a high school education, you guys, within that circle is that one. So it would be 2 all over the total, which is 1,200. So 2 over 1,200, put that in your calculator, you get that. Move the decimal places 2 to the right, and you get 0.16, which rounds to 0.2%. All right, part D. It says earns under 20,000 and has a college degree. So under 20,000 is here, and within there it says and has a college degree right there. So it's going to be 13. So 13 all over 1,200. Make that into decimal form, and the percentage would be 1.1%. Part E, it says employee earns over 30,000 given, remember you guys, this line right here is given. So given has only a high school education. So we have to look at this given statement right here first. So only a high school education. Okay, so going back to the chart, that's only this category, you guys. So that total right there adds up to 224. And then it says find the probability of employee earns over 30,000. So within this circle, you guys, within that realm, over 30,000 people who earn over 30,000 would just be that 14. So 14 over 224. And then find that decimal, move the decimal place 2 over to the right to get the percentage, and you guys get 6.3%. All right, so let's take a look at F. Okay, so for F, it says find the probability of employee has less than a high school education, given earns over 30,000. So given that they earn over 30,000, which is this category. So we have to add all of those up, and we get, I believe, 404. So this total, you guys, is 404. Now that we have the given, now we gotta go for the other one. Employee has less than high school education. So within that given statement, you guys, the one that has less than high school education is that 2. So it's gonna be 2 over the 404. Put down your calculator, move decimal place over to the right 2, and you guys are gonna get 0.5%. And that's the first problem. Okay, problem 2. We got, okay, so we have this chart. The first one says find the probability that it's male. Well, first of all, you guys have to find the total. And the total to this, you guys, is 150. So find the probability that it's male. All you have to do is just add up all of the people that are male and put that over the total. So that's going to be 40 plus 16 plus 35 all over 150. Make that fraction 91 over 150. Decimal, move decimal place over to the right 2 to get it to be a percentage, and you guys get 60.7%. Okay, next one. It says find the probability of male or majors in chemistry. Well, male is right there, and chemistry is right there. Now, do you guys notice that the 35 is included in both? So we don't put 35 twice, right? So we add up 50 plus 16 plus 35 plus 20, because 35 is already included with the male. So we get that. Put it over 150, the total, and it's going to be 0.74, which is 74%. Okay, next one. Okay, probability of majors in physics given if they are male. So remember, this is given, you guys, right here. This line right there means given. So given that they are male, and how many males are here? That is 91. So 91 males total. Now, how many of those 91 males are physics majors? 16. So 16 over 91, and there's your guys' percentage. Okay, next one. Okay, so use the sample space 5 through 14 to find the probability for a randomly selected number. Okay, part A is find the probability that it's an integer. Well, all of these, you guys, are integers. So probability of picking out an integer, 10 out of 10, which is 100%. So that one's 100%. All right, now let's look at part B. Now, this is less than 10 given less than 13. So first, we have to look in the realm of our given statement. So less than 13 is right here. So that's a total of 8 numbers. So that's our given statement. Now, we find the probability that less than 10 given our given statement. So less than 10, and I circled it in orange, is 5, 6, 7, 8, 9. So it's going to be 5 over 8, because there's 8 total numbers that are less than 13, which is right there, and there's 5 numbers that are less than 10 within this. So 5 over 8, 0.625, 62.5%. Okay, part C. Probability of greater than 8, less than 11. So the numbers less than 11 are right here, you guys, which are 6 numbers. So 6 numbers. Now, we have to find the probability that it's greater than 8 given what we have here. So greater than 8, you guys, is 9 and 10. So it's 2 over 6, which would be 0.3333, which is 33.3%. Okay, part D. Now, greater than 12, that's our so probably greater than 7 given greater than 12. So numbers greater than 12 is 13 and 14. So that's 2 numbers. Which one of those are greater than 7? They both are. So that means it's 2 out of 2, which is 100%. That's number 3. All right, so some of you probably have been exposed to this in the past, where you guys had to do like a tree diagram. So let me just read this for you guys first, and then we'll talk about this tree diagram. So it says, Maria travels to school either by walking or by bicycle. The probability she cycles to school is 75.75. If she walks, the probability that she is late for school is 0.1. And if she cycles, the probability that she is late for school is 0.05. So, right? When you first look at it, it's like, oh my gosh, there's just too many words and I don't even know what they're talking about. So what you guys should do is you should just or just look at the tree diagram. And then from your tree diagram, you should be able to mark down what each decimal spot to put. So in this first part, right? So do you guys notice how it says she cycles to school and it's 0.75? So that's that right there. She decides to cycle to school, which is 0.75. Well, if that's 0.75, then the probability that she walks, you guys, is 100, or sorry, 1 minus 0.75. So you guys should recognize each one of these columns or in the tree, they add up to 1. So that should help you guys when you're filling this out. So the fact that she goes 0.75, probability that she cycles 0.75, that means probability that she walks is 0.25 because I did 1 minus 0.75. Now, we move along. If she walks, so we're right here, you guys, the probability that she's late for school is 0.1. So that's why I put 0.1 right there, you guys, because it says it's 0.1. If she walks and she is late. So if she's 0.1 late, then that means she's 0.9 not late, because 1 minus 0.1 is 0.9. So that's that. Now to fill out this one, it says if she cycles, the probability that she is late for school is 0.5. So if she cycles, the probability that she's late is 0.05, which means 1 minus 0.05 represents she's not late, which is 0.95. So that's kind of the process on how you guys fill this out. And then from here, we can just answer some questions. So part B, find the probability that Maria is late for school. Okay, so how many times or how many ways can she be late to school? Well, if she walks, she could be late to school. Also, if she cycles, she could also be late to school. So it has to be the probability that she walks 0.25 times 0.9. That's one possible way that she is late, or she's late by cycling, which is 0.75, and 0.95 that she's late. So we gotta do 0.25 times, oh, sorry. That's if she's not late. Both of these are if she's not late. They should be this if she's late. Sorry. So let's recap. She can walk and she could be late. So 0.25 times 0.1, and she can cycle and she could be late. So 0.75 times 0.05. So you guys multiply each compartment together, add them together, and you guys get 0.0625, which is 6.3%. Okay, moving on. Alright, this one. Again, another tree diagram. So I will walk you guys through this one. Alright, so if you started off like this, right? Now, let's take a look. Look. Okay, so it says if Sharon and Lisa share an apartment. Sharon cooks dinner. Okay, Sharon cooks dinner 3 out of 10. So that's her probability of when she cooks. So 3 out of 10, you guys is 0.3. So this would be 0.3. So if that's 0.3, then that means the probability that Lisa cooked is 0.7, because 1 minus 0.3 is 0.7. Okay, moving along. If Sharon does not cook dinner, then Lisa does. If Sharon cooks dinner, the probability that they have pasta is 0.75. So the probability if Sharon cooks, then they have pasta, it's 0.75. So that means if they don't have pasta when Sharon cooks, it's 0.25, because 1 minus 0.75 is 0.25. Now, if Lisa cooks, the probability that they have pasta is 0.12. So probably they have pasta is 0.12, which means probably they don't have pasta when Lisa cooks is 1 minus 0.12, which is 0.88. So that's how you guys fill out the tree, is you just gotta read the information and put in the necessary spots. Now let's look at this. So part B, it says find the probability that Lisa cooks dinner and then they do not have pasta. So the probability that Lisa cooks is 0.7, which is how we got this. And the probability that she cooks and they don't have pasta, 0.88, which is why you multiply it by there. So that's how you guys get that one. Okay, next. So this is find the probability they do not have pasta. So they can't have pasta in two ways, right? If Sharon cooks, so 0.3, times if she doesn't cook pasta, 0.25. So that's how we get these two. Now, there's another way that they don't get pasta, right? If Lisa cooks and she doesn't create pasta. So 0.7 times 0.8, which is how we get these two. So multiply Sharon's probability of not making pasta plus multiply Lisa's probability of not making pasta. Now we finally have this last one. Given that they do not have pasta, find the probability that Lisa cooked dinner. So given that they do not have pasta, right? Well, we just calculated that probability, right? That given statement, which was this statement right there. So that's how you get 0.691 in the denominator, right here. And then, so if that's the given, then what's the probability that Lisa cooked dinner? Well, the probability that Lisa cooked dinner and that they did not have pasta, which was our first statement up here. So it's going to be 0.616 divided by 0.691. And that's how you guys get 0.891, which is 89% around. Okay. Part 6. Okay, the letters in the word aardvark are printed on square pieces of cardboard with one letter per card. The 8 letters are placed in a hat and 1 letter is chosen at random. Find the following probabilities. So, probability of the letter chosen is a vowel given the letter falls in the first half of the alphabet. So, our given statement is the first half. So, there's 13 of those letters. So, that's why it's under 13. Right? That's why it's under 13 right there, you guys. Okay. Now, probably the letter chosen is a vowel. Well, in aardvark, right? How many vowels are in aardvark? Well, there's 3. So that's why you put 3 on top. So it's 3 over 13 for 23%. Next one. Probably the letter falls in the first half of the alphabet given the letter chosen is a vowel. So letters chosen in a is a vowel. Well, in aardvark, you guys, there's only 3 A's, right? So that's why we have 3 A's, 3 on the bottom for the 3 A's. Now, probably the letter falls in the first half of the alphabet. Well, all 3 A's are in the first half of the alphabet. So it's going to be 3 on top. So it's 3 out of 3, which is equal to 100%. Okay, part 7. I will redo this so that you guys have a clear understanding of this. So, if you had to make a tree diagram, there it is. So, a softball game has 80% chance of being canceled for a light drizzle and a 30% chance of being canceled for a heavy fog when there is no drizzle. Okay? 70% of heavy fog, 30% of rain. So, this one, you guys, is going to be 70% of fog, so that's 0.7 here. That's supposed to be 30% chance of rain, so it's 0.3 there. Now, we can use this information above. Softball game has 80% chance of being canceled for a light drizzle. So that's saying if it rains, then it has 80% chance of being canceled. So that's 0.8 there, which means if they play 1 minus 0.8, 0.2. And the reason why it adds up to 1, you guys, is because 80% chance of being canceled, then it just makes sense that it's 20% for whatever not that is to adds up to 100%. Okay. And a 30% chance. Okay, so when there's no drizzle, that's when it's fog. 30% chance of being canceled. So that's going to be 30% of being canceled if it's foggy, which means if they play during it's foggy, it's 0.7. So that's how you guys make that tree. Now, find the probability that the game will be canceled. 2 ways they can be canceled, right? That times that. So if it rains, it could cancel. 0.3 times 0.8. The other way it could be canceled if it's foggy and if it gets canceled. So 0.7 times 0.3. So add those different segments up and you guys should get 45%. Part B, find the probability there will be a light drizzle. So light drizzle was just foggy, so 0.7. And the game will not be canceled times 0.3. Oops, sorry. There will be a light drizzle, so that means if it rains. So if it does rain and they do play 0.3 times 0.2 for 0.06 for 6%. Okay, so you guys work on this and hopefully this helps you guys out. Okay, peace.